Good morning, students. Today we are going to start our new chapter, periodic classification of element. Here we have to learn about the periodic table. What are the various periodic table? The very early attempt, though they are not called as the periodic table, but they were the only attempt, because in earlier days only limited number of elements were discovered, like even up to the time of Mendeleevs periodic table, only nearly 70 elements was discovered. And in modern periodic table, nowadays what we are using, nearly 120 elements are discovered, and all of them are arranged in that periodic table. So we have to learn about the periodic table. The term called classification. Why this classification? A student, classification simply means the grouping. Why any kind of grouping is required, and what is the basis of grouping? So grouping is always done on the basis of certain common feature or common characteristic. So this grouping based on common feature or common properties. Why? That helps in a study, that makes the study convenient, because in a group, if we are knowing the characteristic of one of the member, then the other member of the same group can be predicted, though there may be slight difference, but most of the property can be predicted. So grouping based on the common feature or properties, that makes the study convenient, that makes the study convenient, and predict the others also. So help in predicting the properties. So that is called the classification, simply means the grouping. Why grouping? To make the study convenient. It is one thing. Now regarding these elements, so if we consider the elements, so it was in 1649 when the first element was discovered, and that element was your phosphorus, P. Later on, in 1817, means up to 1817 or 1820s, you may roughly call, only and only around 30 elements were discovered. So we are observing that with the passage of time and with the development of chemistry, the number of elements discovered were increasing. In 1870s, you may call it, or 60s, exact year not required, roughly you can write. So in the 60s, around 56 element, or you may roughly call this as the 60 also, but write the exact number, element were discovered. Okay, student. And in 1870s, it was 63 element, and in 20th century, means 1910 or 1930, around 110 elements were discovered. So what we are observing, in the later half of this 19th and 20th century, the number of elements discovered have increased rapidly. So with increase in number of elements, it becomes difficult for the scientist and the educators to remember all these elements independently and know their properties. Therefore, an attempt was made to classify based on certain common properties. So we may write with increase in increase in number of elements, or with the discovery of more number of elements, attempts were made to classify. So classify means already means the grouping. Classify for ease of study. And predicting the other properties. So what were the earlier attempts that we are going to write it here? Those earlier attempts are not required to analyze in much more detail. So what were the year and what were the attempt made? That let me write. So years and attempt. Attempt means the periodic classification or periodic table you may call. But the name for initial attempt was not exactly given as the periodic table. And at this time, who had done that attempt, that I will write here. And just for understanding, we will write at this time how many number of elements known, so that they have attempted. Elements discovered. A student, the very early days, the elements were classified into metal and non-metal. So ancient classification we can say, means during the very early days, the elements or the matter itself were classified into metal and non-metal. So very early or earliest classification was metal and non-metal. This was the time of Aristotle, but no need to mug up. So just understand, the very earlier days it was considered the elements can be classified into metal and non, but there were certain elements which cannot be put into this category, like metalloids. So therefore this classification is, or this grouping was not concrete. In 1817, the very first Dauberner have given the idea of triad, that three elements can be grouped together and their characteristics are matching and they are following one mathematical relation, that the atomic mass of middle one is average of the mass of other two remaining, means the first and third in that triad. So that classification is called as Dauberner's triad. So you have to understand the name and you have to just keep it in mind. Dauberner's triad. The triad itself indicates the group of three. So it was group of three elements. Say if you consider A, B, C as the elements with their atomic mass, consider Ma, Mb, Mc, then according to Dauberner's triad, mass of B was average of the mass of A and C. So Ma plus Mc by 2. At this time, only 30 elements were present. And he was able to successfully determine only 4 trads. Only 3 to 4 trads means only 10 elements were following this relation. So those trads are not important for you, no need to mug up, but just for your understanding, you can write example. So the example that we need to keep in mind, that the lithium, sodium, potassium, lithium, sodium and potassium. You are knowing that mass of this lithium is 7, mass of potassium is 23, sorry, mass of sodium is 23 and mass of potassium is 39. Now, if you add this here, 7 plus 39 by 2, what you are going to get? 46 by 2, it is your 23. This is the mass of sodium. So mass of the middle one was average of the mass of the other two in a triad. So element were grouped into the 3. So group of 3 element. Not any of the 3 can be grouped, but 3 which is following this relation means the mass of middle is the mass of the or average of the mass of the other two, that one. So group of 3, so right, in group of 3 elements, the mass of atomic mass middle is average of other two. Only this much you have to keep in mind, that's all. Nothing more than this will be asked. The simple question in MCQ is asked, how many elements were placed together in Doberner's triad? The name itself indicates triad means it is the 3. Only 3 to 4 triads were determined by the Doberner. The first triad was this one. The second, like your chlorine, bromine, iodine, chlorine, bromine and iodine was determined. So chlorine atomic mass 35.5, roughly we can take this as the 35. It is 80 and it is 127. Student, if you wish, you may put the 0.5 also in this chlorine. Roughly you are getting that the middle one is following the relation, adding the first and last, you can get the mass of the middle one. The third triad was your calcium, strontium and barium. Student, you just keep these two triad in mind. The third triad, because remembering the mass is quite difficult, but calcium you are knowing it is the 40, strontium is our 88 and the barium is again 137. Student, so this way. So what was the limitation of this Doberner's triad? So these have the limitation that only though the known elements were 30, but the limitation or drawback was that only these 3 triads were determined. Later on 1 or 2 more triads were determined. So only 3 to 4 triads were found, which was exactly following this relation. Other elements were not following. Okay, it was this one. So it was in the very first attempt was in 1817 when 30 elements were known, and it was the Doberner's triad. So what is the advantage or the credit goes to Doberner's triad? It was considered as the first attempt. Okay, So advantage is it was the first attempt to classify, though it is not successful, though not a periodic table. He could not give the periodic table. So first successful classification, the credit goes to Mendeleev. But before that, even two others are there. I don't think that are required. Let me see your notebook. Yeah, just the name is given. So write Newland Octave rule. The second one is our Newland Octave rule. This was the first classification, student. Mark it in red. The second one is in 1866, when Newland had given the rule that 8 of the elements can be placed together, and it is found that after 8th element, the property gets repeated. That arrangement was also based on their atomic mass. So that is called as Newland's octave rule. Octave arrangement. At this time, 56 element was known. The octave indicate group of 8. Group of 8. From where this 8 was taken? It was taken from the idea of node of this sound, like what they are: sa, re, ga, ma, pa, da, ne, sa. Okay, it getting repeated. So student, in this octave rule also the mass was considered. So no atomic number was discovered, because you can recall the concept of atomic number came in 1922 after the discovery of Rutherford model. So that's why everyone was thinking in the line of atomic mass only. No one was able to think in the line of atomic number, because atomic number was not discovered at that time. Okay, student? So it was found that 8th element get repeated. So it was basically the group of 7, 8th get repeated. So you may slightly correct it. Group of 7 and 8th get repeated. Why it was group of 7, not the group of 8? The cause was noble gas was not discovered at that time. Discovery of noble gas have occurred too late because of its noble characteristic. In initial time, it was the chemical reaction based on which the elements were discovered and they were trying to classify. So right, in this, he had given an octave rule. According to octave rule, the 8th element have same property, have or similar property if they are arranged in increasing order of their atomic mass. In arranging order of their atomic mass. The concept was similar to which one? This is asked in your NTSE and some other places. Similar to the notes or node of the musical instrument So what they are? Node of musical instrument are sa, re, ga, ma, pa, dha, ni. Then after that you are getting again it get repeated for which? Sa. Getting no? Means after this it is going to repeat it. He tried to put it in this category. He was able to put the hydrogen. The helium was not discovered. That's why no question of helium. He was able to put the lithium, then beryllium, then boron, then carbon, put the next one, nitrogen and oxygen. Getting no? After oxygen, what comes next? Fluorine. So fluorine was repeated. This was the only discovery. The fluorine, sodium, magnesium, aluminium. Write down the next one. Yes, carbon and silicon. Then nitrogen, with this the phosphorus was matching, sulfur was matching. So these were the elements. So these were the nodes and these were the elements. So this classification. So Doberner's triad was not at all any periodic classification or any tabular form, but this Octave Newland, this was the advantage, is that it was the first tabular classification. Classification or grouping, the word mean the same. But what was the limitation, student? Limitation was that limited number of were known and noble gas no position, it was not known. So limited number of elements, and even in that limited number of elements, it was 56, it was found that this rule, the rule called Octave rule given by Newland, was following up to 20 only. After 20 it was not followed. So Octave rule was followed for lower elements up to 20 only. Okay, this is enough for this one. Many more are there. No inert or noble gas, it was this one. So these are the things related to Newland classification that we need to keep in mind. Okay, it's all. Next one is, after this, the next came your Mendeleev periodic table. From there, the term periodic table was used. So write down the third one. It is your Mendeleev. Mendeleev was a Russian scientist. So this is called as Mendeleev periodic table, but let us write in the same fashion how we were writing. So it was in 1872 when Mendeleev had given their classification, and that classification was called as Mendeleev periodic table, because the complete table he has formed. Periodic. The term periodic means something get repeated, like the period of day and night. We are getting after every 24 hours, day and night is repeated, so day and night are periodic. A student, at this time, only 63 elements were discovered. And the good thing was that he was able to arrange all the 63 elements in that table. Rather, he had also predicted that there will be some other element which is not discovered, and he had left some vacant position in his periodic table. The only drawback was this arrangement was that certain elements were not following the rule given by the Mendeleev. It was also based on increasing order of atomic mass. So that rule was not followed for certain case, like potassium and calcium. It was not followed. Like the other, some chemical reaction he had carried out. So those things. So let us start with this. So Mendeleev periodic table we have to learn. So it is based on Mendeleev periodic law. According to Mendeleev periodic law, he told that when the elements are arranged in increasing order of the element, or sorry, increasing order of their atomic mass, then after the 8th, 9th will get repeated. That way he had told. So write down Mendeleev periodic law. He proposed that the property of elements are periodic function of their atomic mass. Means if the elements are arranged in increasing atomic mass, then after certain mass, the property will get repeated with their first one. It is that one. So based on that, he had arranged. In addition to this, to verify this, just arranging in order of increasing atomic mass, he had carried out various reactions of each element with the other element, and it is found that oxygen and hydrogen is able to react with most of the element. Therefore he chosen reaction with hydrogen and oxygen, and he formed the compound, and based on the compound the element is able to form, he arranged all the element in tabular form. That's why it was very much successful. So student, write that Mendeleev periodic law, which was based on very first, means this law itself was based on reaction of, this is asked on what is the basis of Mendeleev periodic table. So reaction of each element with oxygen. When the element reacting with oxygen, it is forming the compound called oxide formation. So it was based on oxide formation, and also reaction with hydrogen. So reaction with hydrogen, the compound form is called as hydride formation. Then based on the formula of hydride and oxide, formula of hydride or oxide and hydride we can write, and oxide, the element were grouped into tabular form. Even before this Mendeleev, there is one more, but that is not required in tabular form. It was this one. That's why it is entirely called as periodic table. The other one is, it was found that the elements are able to form only limited number of hydride and oxide, and their hydride formula and oxide formula were get repeated. So this formula of hydride and oxide were grouped in periodic table, which was repeated. How is this? I will just copy from your textbook and I will keep it. The another, it was also verified that this formula is following the increasing order of their atomic mass. It was also following increasing order of atomic mass. So both things are there, student. Many times students are getting confused. So here, very first one is the reaction with oxygen and hydrogen, as well as increasing order of atomic mass. So this was double verification. That's why it was most successful at their own time. And this is the basis of even the modern periodic table also. He had given, this have many advantages. So right, he also observed most of the elements were arranged in order of their atomic mass. Okay, so it was also following increasing order of their atomic mass, with few examples only. Though he had placed, or he had given the priority of the reaction or the compound formula rather than just atomic mass. So with few exceptions, this was known to that person. Exceptions. What are those exceptions? They are also important. So those things we will write. So students, let us copy it and let us put it here so that we can write the various properties. So this was the basis. Newlands, Octave, I had explained. That's all. Mendeleev periodic table, it is very important. See, a student, it is the Mendeleev periodic table. From this, we will write point by point everything. Let me copy it rather than writing. Let me copy it. So let us put the Mendeleev periodic table. Observe it carefully. It is very useful. This is the basis or the characteristic of this Mendeleev periodic table and our modern periodic table. Roughly they are matching. There are only few exceptions, so that we will write few things, important things for this Mendeleev periodic table. Then we will go for modern periodic table. Students, whatever the vertically downward you are considering, it is called as group. So understand the term like group and period here itself. If you are moving downward, say if you are considering this one, the element or this block moving this way, means you are moving downward. So whatever the downward means, this is the one downward path, this is the second downward path. So this downward, these are your group. Correct? So how many groups are there? One downward, second downward, third, fourth, fifth, sixth, seventh, and eighth. So we shall quickly write. There were total 8 group. So in Mendeleev periodic table, total 8 group. It is this one. Now let us focus over the group first. Students, like the first, our second group is this one.
Sir.
Yes.
Sir, vertically downward is given as periods. No?
Vertically downward is called as period.
Sir, arrow is given under periods. Sir, in the figure.
Okay, this figure is indication of the period, you mean? Student, yeah, this arrow, this is wrong. You just, I think you are confusing with this one. Please forget this for a moment, okay? Student, this arrow, the book have represented something else and you people are interpreting something else. Student, here this arrow indicate, Vivek, understand this period indicate that whatever this one is written, it is this one, it is this one. But for understanding the period, you need to go in this fashion. This is the period, okay? So this is the period number 1. So this is our period right here. यही पूछ रहे थे ना विवेक आप, कि और भी कुछ पूछ रहे थे, इसी से कंफ्यूजन था?
हाँ सर, यही पूछ रहा था.
Okay. See, so in this way, this is the first period. If you are going this way, it is our second period. So it is also period. Okay. If you are going this way, it is also the period. So I will come to this. Means मैं स्टेप बाय स्टेप मैं खुद ही सब आपको वहां तक मैं पहुंचता, बट आपको पहले ही डाउट हो गया आपने ये एरो देख कर. If you are coming to this, it was the last one. So this was also a group. This was also group. So this way counting this means the group means you have to count the vertical column. So write this. This group, these are the vertical column. So vertical column were called as group. How many groups are there? We can count it. 1, 2, 3, 4, 5, 6, 7, 8. That's why we have written 8 groups. 8 vertical column were there. Getting? Now in this 8 vertical column, even we are observing most of the vertical column have, see, A and B. So these A and B were called as subgroup. So this 8 group vertical column with 2 subgroup, they were called as subgroup. But there is one exception. Observe what is that? The last one. Observe the last one. In last one, how many elements or the column are going to form? 3. Except the group 8 or group this way, it is 8. So which have this group 8 have 3 column. You have to just understand. The question are not very frequent with this, but this is the basis of our modern periodic table. So that's why we have to understand everything. It is this one. So 8 column, he have arranged the element in 8 column, and each of the or most of the column were containing 2 elements, means the 2 subgroup, but the last one he had put the 3. So this explanation was not given why these 2 and other are 3, though he had given some explanation, but that was still not justified. It is this one. Now coming to the period, the period that we are observing. Students, here this period, and below this arrow is written. This arrow indicates this is the period number 1, 2. So whatever this, I always prefer to mark it here this way. Moving in this way, how many ways you can move? These are your period. Here we are observing the first period is this one. So it is our period 1, period 2. Coming down, period 3, 4, 5, and 6. So that we can write total 6 period. In his time, he had called this as the series. See here, the term series was there. Getting now? Or series. Even in this series, you can observe that this, starting with the 4th, you have the first series and the second series. So 2 sub period. From which one? From 4th onward. From 4th onward, it have 2 sub period or sub series. Or 2 series. Okay, student, it is this one. So total 6, you have to remember these numbers. 8 group, 6 period. Group were subgrouped, period were also sub period or sub series was there. It is that one. Another important thing, how is the arrangement? Now let us come to that. Here you are observing that, student, observe it carefully now. It's very important for you to observe it. Now, coming to this. Come to this top one. Student, do not count this as the period. It is not the period. Okay, no, this is in this table. It is the formula of the compound that is formed. So this is indication of the formula of compound form. If you are considering the element as R by formed by element R. So this element R have to react with what? Our basic law is reaction with hydrogen and oxygen. So this R can form. So we can write it here. So the formula of element R, the element denoted by R with oxygen and hydrogen were taken. So this formula for this R with oxygen and hydrogen. Now, student, you are knowing that oxygen have the valency 2, means -2, or just understand it as the 2. These have the valency 1. Student, if we have this R with valency 1, how many hydrogen it will react? It need only 1 hydrogen. So R with the hydrogen, if it is going to give us only RH, means the R have the valency 1. It will fall in the first group, irrespective of period. So all the period, whether first period or second period or third period, all have the same formula RH. So this will be the formula for first group and all the period. Okay, now though write in bracket all period, whether first period, second period, whatever you are considering, the formula of their hydride form will be the RH. But in place of this hydrogen, if you are taking the oxygen, that you are knowing it have the valency what? 2. So R must present 2 times to form their oxide. So this will also be the oxide formula. So match it, you will get it. See, observe it carefully. It is very interesting and very simple, but the students are not understanding. That's why they are getting confused. So student, the hydride formula is RH and oxide formula is R2O. That's simple. Example could be, you may write this sodium if you are taking with the hydrogen, you are getting NaH is formed. But the same sodium with the oxygen if you are taking, it is Na2O is formed. It is following. Rather than sodium, if you are taking the lithium with oxygen, then you are also getting the Li2O. Lithium with hydrogen, this can be balanced. Okay, no, in place of O, if you are taking O2, that doesn't make any difference in this reaction, but the formula is important here. It is LiH. Correct? So these are the formula. So a student, understand this carefully. The first thing that is written is not acting as, do not count this as the period 1. This is just the, in the table, the space is for indicating the formula. The second one is for indicating the group and subgroup. So it is for the subgroup. So this is group and subgroup. This is your period 1. This is your period 2. In this period 4, we have the series 1 and series 2. Okay, so this kind of classifications will be. Student, this way we have concluded that 8 group, 6 period, and formula of the element determine, or according to formula, it is placed in first group or second group. Say for first group, the required formula for the hydride is RH and for the oxide is R2O. Okay, student. If we go for the group 2, let me write few more for your understanding. So for the Mendeleev periodic table, group 2 element and formula. So the element R. So all those element R which on reacting with hydrogen can give us RH2, and reacting with oxygen is giving RO, were placed in the same. So R could be, it could be like our magnesium, or it was found that the magnesium is satisfying this, calcium is satisfying this, okay, strontium, barium, they are satisfying this, so they were placed together. So see, now let us observe it carefully. See, for the second group, for our second group, we have the formula RO and RH2. For third group, what it will be? RH3. Let me write that one also. For the group 3, R, if it have the 3 valency, then RH3 will be there. Now coming to the oxygen, R with oxygen, what it will be? Oxygen have the valency 2, that way you can keep in mind 2 minus. So I need for this to be third one, what it should be? Like Al3O2. So that is in the third category, or R2O3. Ready? it will be this one. So that the valency 3, so the third group, the third valency, and here this. Oxygen have 2, so R2O3 should be there. Yeah, observe it. Here we are getting the same thing. Ready? Now let us come for the next. Student, what will for the 4 and more? Let us take for the 4, 5 also. For the group, student, you can write few example also. Okay, now like your nitrogen with 3 hydrogen forming HNH3, aluminium with oxygen had formed Al2O3. So this example I think you can write by yourself also. How they have written, I think these things are not written in your book, but how it is placed, you can understand it by taking this. MgO, calcium plus oxygen, CaO. Okay, student. Let us come for the group number 4, where R with the 4 hydrogen they have to combine, RH4, but for the oxygen, this must have the 4 valency, this have the 2, so crossing it, it should be like this one, R2O4. But we are knowing that for writing the molecular formula of a compound, the common factor among all the atoms can be cancelled. So 2 is common, so it should be 1 time, it should be 2 times. So the correct way is RO2. So the formula of oxide will be RO2, and for the hydrogen RH3. Observe it. Yeah, we are getting the same thing. Yes, it is same thing. Okay, student. Now coming to the next one, for the fifth. For the fifth, hydrogen have only valency 1, so by sharing it is satisfying. So again, the formula for hydride will not be RH5, but you can see here it is RH, how much? 3, RH2 and RH1. So let me write that one also. For the group 5, how is the formula? R plus H, RH3. So that by sharing it is able to satisfy their valency and the compound is stable. But coming to the oxygen, no such thing was observed, and he had given the formula as 2 and this as 5. So R2O5 should be there. Okay, it was this one. So observe, it is this one. Right? Similarly, you can understand for the other, it will get cancelled for the oxygen and hydrogen only 2. Let me write quickly. For the group 6, R with hydrogen, by sharing, how much is required? It is able to form 2, and R with oxygen, the compound is like here 2 and here 6. So crossing it, 2, O6, cancel it, 1 and 3 means it is identical to RO3. Right, for the group number 7, the formula is RH, that is able to satisfy it, and R and O are 7, but O2 crossing it, O7. So these were the formula that were considered and they were placed in the vertical one. A student, this was how the formula was chosen. The next one, without hydrogen, it was found that reaction with hydrogen is very much rare for this, and he had given the formula RO4. The group 8 R and oxygen. You may write this as 2 and 8. R2O8, common factor is there, so that can be cancelled. RO4. This is the formula. This group have a special feature that 3 elements were satisfied. Now, these were the formula. Now, coming to this formula, another interesting thing was that the same formula was satisfied by 2 kind of element, though they had different property. Like, if we consider the formula for the first group and this potassium and the copper, it was formed that it was able to form potassium hydride as well as the copper hydride. Okay, but this potassium, these have entirely different properties than this one. These two are different, so that's why they were subgroup. Formula same but difference in property, that's why he had subgrouped. So right here where we have written for the subgrouping, so total 8 vertical column, 2 subgroup. So this was based on, so this 8 is based on same formula of oxide, means each group, basically each group for same formula of oxide and hydride, but this subgrouping was based on different properties with same formula. Formula of what? Of oxide and hydride, students. Okay, and hydride. I think this much is enough for you people. Okay, no more I will discuss, otherwise there are many more things. So this is all about, that's why the 2 subgroups were considered. But coming to the group number 8, it was found that the 3 elements were satisfying same formula, but they had entirely different property. But this property were showing gradual transition, means the property of oxide of iron and oxide of cobalt and oxide of nickel was showing a gradual change, means one to another to third one in their various property, like their mass, their color, all those things. Okay, student, so that's why these 3 subgroup were framed in the group 8. It was this one. So this is all about. Now, what are the advantage and disadvantage? That let us write quickly. What were the advantages? The very first one was, it was the first successful arrangement of known elements. So it was considered as the first periodic or successful classification, you can write. Full periodic table. So after this, a study become convenient. So convenient. This study become convenient. The third one, what it was? All the elements were able to fit into this. All known elements were arranged. It was not only this much, rather this classification was so important or so helpful in chemistry that he had also predicted that there will be some future element for which he had left some vacant space in his periodic table. So write that. He has predicted for few undiscovered element. Means he had told that there will be some element which will occupy this position. Right now it is not discovered. That's why it was very much powerful, or the base of our classification. So predicted for the existence of the future element, for few undiscovered element, and left vacant space or vacant position for those element in his periodic table. Okay, student. So this was the most important feature of this Mendeleev periodic table. Not only this much, we can write what were those elements. Example, let us take one example, what he had predicted and later it came to be true. Example, in the place of boron, after boron, the space was vacant. Students, see here. Where is our boron? So, this boron and aluminium, this one. At this time, these things were not well discovered, and he had predicted that corresponding to this boron and aluminium, the element will be discovered, and later on it was discovered that corresponding to this aluminium, the gallium was discovered. Student, this was discovered. He had left this space vacant basically. And corresponding to this boron, this was discovered. Okay, no? It was this one. So we may mark it in different color. So these were discovered later. So corresponding to this aluminium, the discovery was for the, for this gallium, and corresponding to this boron, the discovery was for the scandium. Getting now? So right here, this block was vacant in his periodic table. So this was, nowadays, since we are using much later than that, and we have fit the later on discovered element also in this periodic table. That's why it is filled here. But at his time, these were vacant. So right here, it was vacant. And this scandium and gallium discovered later. Even corresponding to this scandium, he had told that the name of this element is scandium, the name given later, but he had called that corresponding to boron, one element will exist, and his name he had also told that it should be called as Eka boron. means matching with boron. Corresponding to this aluminium, the discovered element for his, he had given the name called Ica aluminium. So understand, this is very important. No one can understand without this analysis and without allocating in this. In book it is just written, but very difficult to understand. So just keep in mind. So this scandium, which was discovered later, but earlier name he had, this Mendeleev had called this as Ica boron, and gallium as Ica, which is, it is corresponding to aluminium. Getting? So these things. Now I am going to write these things there. I hope you people are getting. If you people are not getting, then please interrupt. Otherwise, if I hope you people are understanding, because I am first explaining everything, then only I am writing. So he had predicted few undiscovered element. So example, whatever his prediction, he has prediction for the element, means the space after that boron and aluminium was there, for Ica boron, for Ica aluminium. So boron and aluminium was known at that time, but after this boron and aluminium, the other place was vacant. What was the vacant position, student? Student, here this position was vacant. Are you getting? This position was vacant. Later on it was discovered and it was filled. Getting, no? With the discovery of scandium and gallium. So it is this one. So that's why we are writing, he has predicted for Ica boron, means boron was there. So similar to boron, some element will exist. Similar to aluminium, some element will exist. And it came true, and it was discovered later as this Ica boron. The element found was scandium. Write the name, the symbol SC we are using. For Ica aluminium, it was discovered for gallium, Ga. Even the silicon was known. I think this element you can remember more easily. The third one was for the silicon, also the similar situation was there. Where is our silicon? The silicon was known, but this germanium was not known. So for this, he had left this space vacant, and later on this germanium was discovered. So let us skip one more. Ica silicon. This Ica silicon later on discovered was our germanium, denoted as Za. A student, what was the property? The property was based on the chemical formula. Even he had also given the formula for that. The formula, atomic mass, all these things were also quite matching. So example, you can write for the Ica boron. He had predicted, say for the Ica boron, what was his prediction? He had predicted that the mass will be around 68. And he had also given the formula of oxide of this Ica boron will be your E2O3, corresponding to that group. Later on, it was discovered that this scandium was discovered later, and it was found that it was matching with this number. Say for gallium or scandium we can write, because both were following in the same group and they are in the same group. Okay, now in group number, student, you can just observe once more. Say it was the group number 3 for the boron and aluminium. So same formula. Getting now? Whether you are going to write for a scandium oxide and a scandium hydride, or gallium oxide and gallium oxide, but their property were different. So based on that, it was considered. So students, for this, if you write the formula, let me write for the gallium. So it is nowadays this compound is formed, Ga2O3 is now formed. Same way scandium oxide is also formed. Okay? So what he had predicted, the formula will be similar, the atomic number will be nearby this one, everything was matching. The atomic number for this, he had predicted nearly it will be 68, and it was found to be around 69 have this scandium have the atomic number. Okay, so this way it was a very solid proof, because which was based on the chemical reaction and the practical observation. So it is very important. So prediction of undiscovered element. A student, even he had also predicted for some noble gases which are not reacting. So write that. 5.
Sure.
Yes.
So scandium atomic mass is 44.
It is gallium I have written. Student, it is this one. Okay, cut it. It is exactly, if you go, it is 69.8 or 9, means nearly 70, not even 69, but nearly it was matching. So right, prediction of the noble gases also. So this was the other important prediction or advantage. So these were the advantage of Mendeleev periodic table. Now what were disadvantages? So write down the disadvantage, or rather than disadvantage, we shall write the limitations. Right, limitations. Limitation, here you can observe that the hydrogen, nowadays it is exactly placed here, but while Mendeleev was trying to put this hydrogen here, for the hydrogen RH and RH, the same molecular formula. So hydrogen at this first group as well as in 7th group was placed. Means hydrogen can be placed in first group or in 7th group. So anomaly was existing there, because of which one? The same formula of their hydride form. Getting? So position of hydrogen was the great anomaly. It was this one. Still this exists in our modern periodic table also. So right, first one is our position of hydrogen. Can be where? In group 1 and also in group 7. Why? The same formula, it have the RH and this also have the RH. It is group 7, student. Getting now? So that's why the position of hydrogen was anomalous, because the formula was matching with the group 1 as well as group 7. It was this one. This was one of the drawback. Now let us search some other drawback. Students, observe this. Our second law tells that, or it was observed that atomic mass is increasing. So is it strictly followed? Observe carefully what you are observing. Yes, students. Can you observe here? Nowhere you are able to observe. Observe from the end this one. Cobalt and nickel. Cobalt have higher atomic mass than nickel, but cobalt is placed before this nickel. Okay, student? Another, what else you can observe? There are also many elements. What you are observing, a student, observe it. Aluminium and silicon. Is it increasing? No. So for few elements, the increasing order of mass was not followed. So write it. Write on the second one. For few elements, the order of increasing atomic mass was not followed. Okay, students? Example, we can write here what they are. Just I have told you.
Silicon and nickel.
Good. So it is our aluminium placed before silicon, though mass of aluminium is equals to how much, and mass of silicon, let us exactly compute from there. Observe it. So for aluminium it is 29.98, but for silicon it is 28. So roughly you may keep in mind that it is 30 and it is 28, already known to you people. So aluminium is our 30, around 30 you can write, no need to exactly write in decimal, 30 U or 30 AMU, and for the silicon mass is 28 U. Okay, student? So keep this example, it is quite common. It is also. Other, what was there?
Silicon and nickel.
That we have written silicon aluminium. The other was nickel and here we have the cobalt and nickel. We are observing that nickel is slightly lighter than cobalt, or cobalt is slightly heavier than nickel. Cobalt. Cobalt. Yes.
Yeah, aluminum atomic mass is 26.
Aluminium 26 or 28?
So it is atomic number is 13. So
Then atomic mass is double of that. Student, do not think atomic mass is always double of that. Atomic mass is your proton plus neutron, it is both one. Okay, you please verify with the other sources. We are getting from this table that aluminium is heavier than silicon, it is one. We can search for the other element also. Getting? If you have doubt, you can search in the net also. Aluminium is slightly heavier than this silicon in their atomic mass. It is not the atomic number, it is the atomic mass we are right. हाँ बोलिए.
Sir, in net, aluminium's atomic mass is 26.98.
Okay, it is nearly that. Okay, but in this table it is written as, so from this table we have observed, I think we shall correct this, or whatever observation at that time, it is based on that one only. So based on that, it is taken as the 29. So that can be taken. But the better one, you can take this cobalt and nickel also. So put it, even more elements are there. More common are what? Your argon and potassium. Nowadays it is argon and potassium, but argon is not here. So that will create problem with you. That's why I want to avoid it. So write down the second group. Put it here. Cobalt placed before nickel, though cobalt is slightly heavier. It was at that time, it is known that cobalt is heavier. The other even,
So,
tell me.
vanadium and chromium.
Good, that can also be taken. Another here you can observe that argon and potassium. Argon is your 39.91 and potassium it is 39.1, that you can take. So keep any of these things in mind. Better you use this example, cobalt and nickel and argon and potassium. More are there, you can observe it from this table, you can get so many. What else are there, student? Chromium and what is this? Vanadium.
Vanadium.
Yes, vanadium. This you can also remember, but it is difficult to remember for vanadium, this chromium. So remember the simple one. The simple one is our argon and calcium or potassium, we can keep like that way. You can also search, so many are there. Observe this group, you can get the same kind of thing. Are we getting the same thing we are observing here? So many are there. You can take the other example, avoid the aluminium and silicon because nowadays it is being corrected. At that time it was initially considered this one, so they had, I think, keep it like this. But better one is this 26 point, how much? 26.8 or 1?
9.8.
Okay, so we can keep it 9. Okay, leave it. So these were the limitations. So student, for you please keep in mind the limitations of Mendeleev periodic table. It is asked position of hydrogen and some of the limitations like cobalt and nickel. It is more important, or this is always asked, cobalt and nickel. The main advantage was the prediction. Here you have to focus for the prediction of noble gas and prediction of some of the unknown element. The other major limitation was, let us go for the third limitation. Student, we have learned about the isotopes. What is this isotopes? Yes, elements having same atomic number but different mass number, then where to place it? if it is arranged in increasing order of mass. So position of isotope was not defined, was not given. Okay, student. So isotopes, they have same atomic number but different mass number, and here we are getting that the classification is based on their mass number. The different mass number means different element, place it in different column. That was the concept. So therefore the position of isotopes was not given. These were the three important limitations. Get it? Because on changing the mass number, it need to be given different positions. So that's why it was not well defined. So these were the advantage and limitations. A student, sometimes it is also one more disadvantage or limitation is there. So predicted number of elements will be there. I mean, he had predicted for some of the unknown elements, undiscovered elements, but how many are undiscovered? That was not given. So people start expecting too much from this table, and they have also given one limitation that number of elements or undiscovered element was not given. Though predicting the possibility of element, that itself was a great achievement. So write down that one also. Number of undiscovered elements was not given. These were the limitations. So this is all about our Mendeleev periodic table. Now let us go for the modern periodic table. Students, so the fourth, we have reached to the fourth one now. It was the year 1913 when Moseley have given the arrangement. G.J. Moseley it is. Just keep in mind the Moseley arrangement or periodic table. At this time, around 100 of elements were known. Around 110 elements known or discovered. So this Moseley periodic table is more acceptable and we are using even nowadays. Therefore, it is also called as modern periodic table. So right, whether Moseley periodic table or modern periodic table. A student, observe carefully, in 1913 he had given. But if you could recall, then you can recall that in 1907 the atomic structure was by Rutherford, and that Bohr model, it was given. Bohr model comes later, but by the Rutherford it was given, where the concept of atomic number arises. Okay, because of the discovery of proton. The proton was discovered in 1986 and this electron was discovered in 1898. That time, that's why in this 1930 it was the concept of atomic number was prevailing, and it was known that atomic number is more fundamental than mass number, and Moseley was quite intelligent person. He has put all these discovery and applying all those, he has tabulated the non-element in the order of the atomic number rather than mass number. Okay, student? So it is the atomic number. So it is based on increasing atomic number. And he had given his own rule called modern periodic law or Moseley law, which tells that the elements are periodic function of their atomic number. Means if you are going to arrange the element in increasing order of their atomic number, then after certain interval the properties get repeated. That's why it is called as periodic. Okay, so based on increasing atomic number in form of modern periodic law, in form of modern periodic law, or also called as Moseley's periodic law. The term periodic itself tells that it is being repeated at a regular interval. Like pendulum have some period. Okay, means the bow will repeat its path after a certain fixed time. So this repetition at regular interval, this interval cannot be in the term of time, it is in term of number of element, interval of elements, when they are arranged in increasing order of their atomic number. It is this thing. So this law, even what is this law, that I will write in complete detail. So during this time, 1930s, it was discovered that atomic number is more fundamental than which one? Atomic mass. So atomic number is more fundamental than atomic mass. Why? We are knowing that atomic number, Z is number of proton, and atomic mass is given by A as proton plus neutron, or Z plus N. It is this. Why this atomic number more fundamental? The concept of electronic configuration was discovered as this number of electron is same as number of proton, and this electron arrangement gives us electronic configuration, and electronic configuration decides your valency, and based on the valency the chemical property is decided. Chemical properties of the element is decided. So that's why atomic number is more fundamental than atomic mass. This question is asked for 1 or 2 marks. So write atomic number. Why? That reason I am going to write. So write atomic number gives the number of proton and electron protons and same number of electrons for a neutral atom. Hence, electronic configuration and after knowing this electronic configuration, the chemical properties of the element can be predicted very easily, because this electronic configuration gives the valency, which is the combining capacity. So the chemical properties. So the chemical properties can be predicted just by knowing their atomic number. For observing this chemical properties, the Mendeleevs have done tremendous work. Mendeleevs have done so many tasks, so many reactions, but this Moseley have intelligently included everything in single statement. That's why it is more popular and even acceptable today. So the chemical properties and the chemical formula of its compound form. Okay. Therefore, all the properties are known with the help of their atomic number. So this is the cause why atomic number is considered. So atomic number Z is more fundamental than what? The atomic mass A. Okay, this is asked. Okay, now student, what I am writing is all are very important. Only those things I always used to write. What is even asked and about to ask. So that's why please remember all this. Now, with the discovery of this atomic number and knowing the concept that atomic number is more fundamental than atomic mass, Moseley had given the periodic law, that is called as Moseley's periodic law or modern periodic law. So right, based on, so what is the modern periodic law? Modern or Moseley's periodic law. Write it. Modern or Moseley's periodic law. Periodic law means what? The law used for making the table. What is that? According to Moseley, it was known that the atomic number are more fundamental than atomic mass. So, while arranging it in the order of increasing atomic number, it was found that the property gets repeated. So this repetition is called the periodic law or periodic function. So he had given in this form that property of an element, or properties of elements are periodic function. This is the term used. So periodic function of their which one? Atomic number, student. So the statement given is in this form only, but explanation of this statement sometimes also ask, what do you mean by property of an element or periodic function of their atomic number? The means. So if it is asked to explain this, you will write this one. If you are going to arrange the element in increasing order of their atomic number, then after certain interval the properties get repeated. So this repetition in property is called what? Periodic function. But this periodic function occur when the elements are arranged in order of increasing their atomic number. Okay, now students, so it means, or the explanation, this statement explanation is also asked. So students, the two are important in this, starting from this one, either atomic number more fundamental than mass number, it is asked for explanation, or this statement is asked. So right here, when elements are arranged in increasing order of atomic number, this time you have to keep in mind it is the atomic number, then the properties of other element get repeated, then property of elements get repeated. What you found that if you are taking this as lithium, beryllium, boron, and go on increasing or writing like that, lithium, beryllium, boron, what after that? There is carbon, nitrogen, oxygen, fluorine, the inert gas was also known. Then after this, if you are putting the sodium, magnesium, aluminium, it was found that these elements are exactly matching with this one. Okay, means the next slab can be directly put below it. The magnesium is going to match with this one, aluminium is going to match with this one. The same was the observation of the Mendeleev also. So it was this one, but it was not only in this fashion, it was also observed that there are certain elements which is showing slightly different properties, so a gap was kept. Okay, and considering the valency, the periodic table was not in the form of a square, like it was not like this one, means all are filled as it is, every element is filled. No, it was found that some of them are matching, so the structure goes like this. You will observe like this. Getting now? So how is this a structure? Let us take the periodic table, then we will write the property. Very simple. Then only 4 or 5 trendings we have to write. I think in another nearly 40 minutes we are able to finish this. A student, it is this one. So let us take this. Let us keep it here. So this is our modern periodic table. Students, there are few things that we have to keep in mind. How is the structure of this table? Here we are observing that there are two series which are outside the body. So these two series which are not given the place in the main body, one is called as lengthened series. Series means in the horizontal form. Another is actinide series. So not in main body of modern periodic table. So this is sometimes called as one of the limitations also, a limitation. Okay. But if we come to the main part, then observe it. The vertical columns are called as group, like in Mendeleevs periodic table. So here, how many vertical group we can make? 1, 2. So we have to look it vertically downward. Okay. So these are the group number. Here you are getting the group number is already given here. 1, 2, 3. This way 18. So write it. Total 18 groups. Okay. So very first thing is done. Now coming to the period, the horizontal one is called as the period. Means this way, this one, and which will fall in this? It will be the 2 only. Okay. Another coming to the second period, it will be this one. Coming to the third, so on. Coming to the fourth, it is this one. So how many are total there? Total 7. It is this one. So there are 18 group, 7 period, and these two in this fashion it is taken as a series. It is the series. So two series, one is called lengthened series, another actinide series. So total 18 groups, 7 period, and 2 series outside main body. Outside main body. Why outside? Because they have different kind of cells called F cell. So more detail you will learn in higher standard. So they are forming the SPDF block element. So because of the F orbital, they have entirely different characteristic. So it is basically the block wise. This classification is block wise. So 18 group, 7 period, 2 series. It is this one. Now let us come one by one for this thing, what they are and what are their properties. Students, here you can observe that if you are considering to group 1, what is group, what is period, shall I write? The same thing, student, many a time define group, define period, it is also asked. So write group, these are vertical column in periodic table. So total 18 vertical columns, so 18 group. What are the properties in this group or trending, that we will write. So trending in group means while you are going downward, say if you are considering the group 1, which is containing the hydrogen, lithium, sodium, potassium, rubidium, cesium, francium, you can observe that moving downward, it is found that potassium is better metal than lithium, even sodium. Then cesium and francium are so metallic that they can show photoelectric effect. Means what? Even if the light is falling on it, the electrons are able to come out of their surface and able to move into the environment. They are so free that these electrons can be lost very easily. So electron losing capacity increases down the group. These are called as what? Trending. So what are various trending that we will write? So trending in the group, that we will write. But another thing, if we are going to arrange this based on their electronic configuration, then all have the same number of valence electron. Okay? Like group 1 have 1 valence electron, 2 have 2 valence electron. That doesn't mean 8 have 8 valence electron and 9 have 9 valence electron. No. Again, the block wise you need to manage. So for that, the configuration, electronic configuration based on SPDF is required, but this kind of configuration is not required for you, or not asking you, or not taught even in class 9th. So that's why this block wise analysis is not required. So we shall just keep few things in mind. So each group have same number of valency and valence electron. Electrons and valence. It is this one. If you are moving down the group, you will observe that the sodium is of bigger size, even potassium is much more bigger. The rubidium, cesium, francium is even bigger than that. And if we go for the electronic configuration, then we can find that lithium have the atomic number 3. Configuration is like the inner one orbit have 2 electrons, and after that the valence shell or valence orbit have only 1 electron. If we consider the sodium, then for the sodium the atomic number is your 11. Go for electronic configuration 281, arranging it is nucleus, only 2 electron will be there, then 8 electron will be there, then only 1 electron will be there. So here there will be 8 electron. These have the 2 electrons, but this one have the only 1 electrons. Only 1 electron. Okay. So here we are observing that from lithium to sodium, if you are going, then the number of valence electron, means outermost electron or electrons present in outermost orbit, remains the same, and it is 1 and 1 only. But the number of cells have increased, because for the lithium the electronic configuration was 2 and 1. This 2 was in K cell and 1 was in L cell. But for sodium it have gone to K, L and M cell. So we are getting that moving down the group, the valence C remains the same, but number of orbits have increased. Like it is your KLM orbits. So right, each have the same number of valence electron or valency. So moving down the group, the means after each you are getting new cells are added. New cells or orbits, okay, no, are added. Just moving one step down, only one orbit will add. Moving two step, two orbit will get added. So while new cells or new orbit are added, so what will happen to their size? So the size will increase. Getting? So here you are getting that for accommodating more electrons, the size of the atom will increase because more orbit is there. So moving down the group, new cells get added and the size of atom, the size of atom, how we can get or how we can give the size of a football and a tennis ball in terms of their radius. So what is the radius? Based on that it is given. So whether size of atom or atomic radius, radii, whether increases or decreases, increases. It is very important. Okay, so in a group the atomic radii increases while moving down the group. Example, if we consider this size wise, so size of lithium will be smaller than sodium, will be bigger than potassium, than rubidium, cesium, francium, or only 2 to 3 is asked to you. Cesium, francium. The same is also true. Here I have taken the reference of first group. Even if you go in the second group, so in first group, if you are going to the second group, what is the second group, students? Here we have the beryllium, magnesium, calcium. Going same way, the size of calcium will be bigger than magnesium, magnesium bigger than beryllium. So beryllium, magnesium, calcium, then strontium, then barium, then radon. So right, this beryllium, magnesium, calcium, just keep this much. Only these three are more important for you. If you wish to write from this table, you can also write the strontium, barium, and radon. Strontium, barium, and radon. Okay, it is this one. So all these are in second group. So this way, this hold good for all kind of element. Similarly, we may take from the last one also. From here, what we can say? Say for the fluorine, chlorine, bromine, iodine. Let us write that one also. Fluorine have the smallest size. Chlorine, bromine, iodine, and statine. So fluorine, chlorine, bromine, iodine, and last one is your statine. Okay, no? Only keep this much, iodine. This is enough for you. So this is which group? In 17th group. So this trending, whatever the trending we are discussing, holding good for this size. So atomic radii or size increases. It is one thing. Now let us go for the other thing. How is this? On moving down, new cells are added. While you are moving from first period to second period, one of these cell will get added even in the same group. Like this sodium, potassium are falling in the same group, but this sodium and magnesium, they are falling in same period. You can mark it here. If you are observing it here, you are getting that sodium, magnesium, they are falling in same period. But if you are considering the sodium and potassium, they are in same group. So for an element, you may consider the group wise or period wise. Okay? Going ahead, you may get for the aluminium and silicon, sulfur, so on. Okay? Right now we are discussing for the group wise. It is also possible for the period wise. We will observe that for the period wise, the atomic size go on decreasing. Therefore, size of magnesium will be lesser than size of the sodium. Why so? We will write later that in magnesium and sodium, only the number of electrons have increased. New cell are not added. Therefore, nuclear charge have increased. So this higher nuclear charge can attract the electrons toward itself. Therefore, the size get shrink. That we will write for the period. Now, student, coming for the group, few more things about the group we have to write. In this group, we are getting that electrons and electronic configuration are the same. So same electrons, same valence electron, not the total number of electrons. But a new cell is added, it is two things. Now, while the size is increasing, then the tendency of nucleus to attract the outermost electron decreases because it gets shielded by various electrons in between there. So let us understand that property. So as a result, the tendency to lose electron from the outermost orbit increases on moving down the group. So, right? Moving down the group, we are talking in the group. So moving down the group, the tendency to lose electrons increases. Why? Because new cells are added. New cells added, or the size of atom increases. So the inner electron are acting as the shielding to the outer one. So if something is far away from you, then controlling is very difficult, or attraction decreases because nucleus is positive charge, electron is negative charge, and we are knowing that this force of attraction varies a square of their distances. So observe this. If we are considering the sodium and another as the potassium, write down their electronic configuration: 281, 281. Sodium can be represented by nucleus. One is our K cell, L cell, M cell. But for the potassium, we need to put the K cell, L cell, M cell, and even after this M cell, one more cell is there. So here we are getting that the size have increased. One thing, in this K cell, we have only 2 electrons. In L cell, there are total 1, 2, 3, 4, 5, 6, 7, and 8 electrons. In M cell, how many electrons? Only 1 electron. This is representation of KLM. Okay, now student, are you forgetting the concept of class 9? Then very difficult. Again, KLM and N cell. 1 electron, or how much orbit can accommodate electrons? It is following 2n square. In with this, outermost can accommodate 8 electrons. Considering these two electronic configuration is written. That's why we have written like this. For the potassium, again the K cell, L, M and N cell. Then there is 8 electron. For M cell also it have 8 electron. But for N cell we are observing only 1 electron. Getting? So here you are getting that this radius is RNA is smaller than radius of RK, potassium. Okay, student? This is the RK, radius of potassium I am denoting. This is the radius of sodium I am denoting. Okay, student? So see, and since this force of attraction between nucleus and the outermost electron decreases drastically with increase in size. So force and since is inversely proportional to a square of the radius, the same as follows for the laws of gravitation. But this between the two charges, the force is given by Coulomb's law. But this inverse square law is also followed there. The formula is given by Q1 Q2 by R square. In below there is K, or K can be written as 1 by 4 pi epsilon 0 epsilon R. Okay, this formula no need to mug up. It is the Coulomb's law for force between two charges. So here it is following inverse square. So because of this inverse square law, what we can get? Just opposite. If the radius is more, the force will be lesser. So the radius of sodium, it is the force of attraction basically. So this is attraction because one is positive, one is negative. So attraction force. So in this case, we can write force of attraction in sodium is much greater than, because of this square characteristic, than force of attraction in the potassium. So this force of attraction, that is force of attraction toward the outermost electron, have increased or decreased? Students, decreased. For outermost electrons or valence electrons have decreased. Now, when the force of attraction have decreased, so the outermost electron can easily be removed, or the electron or this atom can easily lose their outermost electron. Okay, so that's why we have written, moving down the group, the tendency to lose electrons increases because new cells added, size of atom increases, and force on or force of attraction of students, you are there? None of you are speaking. Hello.
Yes, sir.
Okay, just wait for another 10 minutes or 20 minutes. We are able to finish this chapter comfortably. So force of attraction decreases. So of attraction for outermost electrons decreases. Even this itself have a big analysis. Even the inner electron which are added in this, they are also acting as shielding for the outermost orbit. That is called as the screening effect. So screening effect also increases, but these things are beyond to your scope. So leave it. Just you write this much. So the tendency to lose electrons increases because this force of attraction for this electron decreases. So this tendency to lose electron is called ionization potential, which is expressed in the term of metallic characteristic. Metallic characteristic is what? How easily the element can give their electron or their free electron. That we have learned earlier. So as a result, on moving down the group, the electron losing tendency increases. Therefore, the metallic characteristic also increases. So that we will also write. So student, understand this. Everything is in these two things only. One is adding new cell, and another one the result of new cell. What is going to happen for the size? Because of that size, the force between the nucleus and electrons. So considering those things, we can answer each and every concept. So here we have written force of attraction for outermost electron have decreased. Therefore, tendency to lose outermost or outer electrons increases. So when the tendency to lose outer electrons increases, what about its metallic characteristic? Therefore, the metallic characteristic increases. So this is about the metallic characteristic. All are interrelated. You just understand few things. Other thing you can predict very easily. Get it? So the metallic characteristic increases on moving down. So which one will be better metal? Whether if you consider the sodium or potassium, which one is better metal in sodium and potassium? Sodium will be better metal. Okay? Correct?
Sir, potassium.
That's why I'm asking. You people are, it means sleeping. I have written here moving down. Means the bigger the size of atom, that will be better metal. Means that have better metallic characteristic. Metallic characteristic itself, the meaning is to lose the electrons. So here we shall write for it is the better metal. Get it? So for we can arrange the element in order of their metallic characteristic. So write that even therefore metallic order what we can write? Sodium is poor metal in comparison to potassium. Same we can take for the other. Yes, student, can you people tell me for the magnesium and calcium, which one will be, and aluminium, which one will be better?
Calcium.
Yes, the calcium. Why? You can observe that magnesium and aluminium, they are in the same period, but calcium is below it. So the rule of moving down is applicable here. So calcium is better than aluminium and magnesium. Now for magnesium and aluminium, we will learn in period. There we will see moving toward right, the metallic characteristic decreases. That's why at the right end there is total non-metals. Getting no? And all the metals are placed on the left end. So right, the metallic characteristic wise, we can write here also this magnesium better calcium. But for these three, if you want to write, calcium is the best than magnesium than the aluminium. Right? But with this, one may think we shall use the wire of calcium rather than aluminium. There are many other factors in making the wire, like their abundance, how much they are existing, how is the cost, what is the strength of that material if you are drawing it into the wire, means the ductility, malleability. So considering those factors, aluminium is used for transmission line, not the calcium and magnesium. Though calcium and magnesium have the better metallic, means better conductance than the aluminium. Ready? There is some other feature like intertransition. That's why gold is considered as the best one, but those things you will learn in class 11th and 12th. So student, here we have understand about the feature called metallic characteristic. We have learned about the feature like the electron losing characteristic. We have learned about, so all these are the trendings. Learn about the atomic size or atomic radii. We have learned about the valency. So valency or valence electrons remains the same whether you are moving down or up to the group, but the other things are changing. So these are called as the trending. So we have written these trendings here. Okay. A student, in NTSE, this characteristic of losing electron, so losing electron is not by itself by any element, but for losing electron some extra energy is required if you want to take the electron out from a metal. Means if this is the metal, I want to take electron from this, I need to supply the energy. Like if you are giving the more heat, even the electron get excited and that is even possible to come out. Falling light, like in case of cesium and francium, electron are able to come out. Okay, so this thing. So how much energy is required to take the electron out means is tendency of losing electron. So energy required will be lesser if the tendency to lose electron is more. So electron losing tendency increases means the external energy required to remove this electron will decrease. Getting? So that external energy required to remove electron from an atom is called as ionization potential. So this ionization potential term was asked in your NTSE. So that's why we shall write this. So write better electron losing tendency than lesser external energy required. External energy required. A student, electron losing tendency means this is expressed or measured when the element is forming the compound, but energy required to remove electron, this is expressed while we are removing the electron for some other purpose, for in our laboratory, or the forced kind of reaction in those places, or even the reaction can also be understood in the term of the external energy required. Okay? Even during the rearrangement of atoms to form new molecule, this energy is required to break the older bond and form the new bond. So there, one of the part is this external energy required, called as ionization potential. So better the electron losing tendency, than lesser and external energy is required to remove an electron from an atom, and if this electron is removed by supplying external energy in gaseous phase, that is called as ionization potential. Therefore, it have external energy required is lesser. So external, how much external energy required, that itself is called as ionization potential. So therefore it have, write it here, it have lower ionization potential, ionization energy, or ionization in place of energy, it is also called as potential. As the name itself indicate, ionization potential or ionization energy is what? The energy required for an atom to convert it into ion in the gaseous state. So it is energy required to ionize it. But this process must occur in gaseous phase, otherwise there is some other kind of energy required. Like if it is in solid, first it need to be converted into the gas by supplying melting point, boiling point, then gas, then if it is in gaseous state, over that means from that gaseous atom the electron have to be removed. So that part is called as ionization energy. So energy required to ionize it. So this ionization again should be monoanion formation, not two electron. Ionize it by removing one electron in gaseous state. Okay, it is this one. So definition are rarely asked, but this order is asked. So what is the order of ionization potential? It was also asked in, let me write for the barium, calcium, magnesium. Let us take only these three. What is the order? Can you people predict? Yes, students? If you wish, you may put one more. So student, here we are observing, you observe the group, observe it here and quickly you can write it. In the group we are getting that barium is at the top, so barium have maximum ionization potential and calcium have the minimum. So order of IP, the calcium have the minimum, means ionization potential you need to think in the term of external energy required. So calcium need the minimum, magnesium more than that, then barium that. So that's why this is energy required. Getting no? So how much energy is required? If more energy is required, then ionization potential will be more. If lesser energy is required, ionization potential will be less. That is, ionization potential is same as energy needed. Getting? If more energy is needed to remove electron, then its ionization potential will be more. So this, here we can also conclude metallic characteristic is also proportional to characteristic is same as or identical to ionization potential or not? Or just reverse of that? Student, here we are observing that lesser the ionization potential, better will be the metal, because metallic characteristic in the term of how easily it loses electron. So that's why the order you have to take care. So how easily it loses electron, and for losing electron it is energy required. So if the energy required is lesser, then it will be better metal. So right, lesser energy required, that is lesser the ionization potential, like here the calcium is have lesser or least ionization potential. But if we consider the metallic characteristic, then this barium is have least metallic, magnesium and calcium is the best metal. So whether it is asked in the term of ionization potential, metallic characteristic or size, the same is also, this is identical to your size. Okay, so ionization potential is inverse to their size. So right, lesser the IP, better the metal, better metallic characteristics. So these three are interrelated, then they are asked. Metallic characteristic. So lesser the ionization potential, better the metallic characteristic. So a student, understand this, size increases when we are going down the group. In down the group moving down, size increases, their radius increases, their metallic characteristic increases. What about its potential energy or ionization potential? That decreases. Okay, student? But ionization potential IP decreases. Getting no? So these things you have to keep in mind. All these are related to their size, their metallic characteristic, ionization potential, their size, all these things. Even energy required, or ease of losing electron, ease of losing electrons, all this. So easily it can lose, it increases. So this was all about the trending in a group. We have learned about their ionization potential, their metallic characteristic. So student, whatever we have learned in this trending, everything I have summarized. So please do not forget this final statement. This is when we are moving down the group. Getting no? Yeah, tell me. Any doubt, then please ask. There are certain other properties also, but those things are not required. A student, there is another condition called electron affinity. Here we have observed that losing electron losing characteristic increases. But what about electron gaining characteristic? So this indicates that electrons gaining characteristic, if it is asked, whether it will increase or decrease. So gaining characteristic will decrease. It is just opposite to that. But this gain characteristic or electron gaining is not possible in metal. It is possible in non-metal. So this trending also hold good for non-metals. Okay, students? But it is not only that much. There is another factor that come into picture called the size. So considering those things, the size and electron affinity, we are going to see in the period. So electron gaining capacity, but still if it is asked, electron gaining capacity down the group for the metals, it decreases. Getting? But for non-metal, it get increases because of their bigger size help in accommodating the external electrons. Get it? It is like that. So students, this was all about the group that we have written. Now we are going to write all this trending for the period also. So write for the period. We have observed that there are total 7 periods. How is this period? Period is based on number of orbits present. You can observe, if you have the hydrogen, the configuration is K, only 1. The lithium atomic number is 3 and it is K1 and sorry, K is 2 and L is 1. Okay, you may write the atomic number. If you are coming to the next one element as the sodium, then KLM, 3 cells are there, 2, 8 and 1. The atomic number of sodium is 11. Coming to the potassium, atomic number 19. Yes, students, you can write for the potassium also. It is our KLMN. It goes to this one. So it have 2, 8, 8 and 1. This much electron. This is in your period 1. Well, hydrogen, another one is helium also, which have the 2. Many more are there. So this is in the period 2. What you are getting in period 2? 2 cells or 2 orbits are there. For all the element in period 3, there are 3 orbits. Even if you are considering this magnesium, how many electrons are there? 2. So just do it. Do the electronic configuration 2, 8 and 10 and 2. So how many cells are there? 1, K, other L and N. So this indicates that there are 3 cells, so magnesium will also fall in third group. Okay? No, student. Number of cell is telling us what? The period. So 3 third period. But this is the valence electron. So this valence electron gives us the group. But this number of cells gives us the period. But do not think just valence electron can give us the group, because the block SPDF is considered. So you have to keep in mind 2, 8, 10 and adding and adjusting it to get the exact period. That I will tell you right now. So student, right? In our modern periodic table, there are total 7 periods. So each period have what is same? Same number of cells or orbits. Have same number of orbits. Means no new orbit is added in same period. Whether it is the group 1 or group 10 element, if they are in same period, they have the same number of orbits. That we will say. That is, this is asked in other way. Orbits get added in option 1, group, period, both, none. So question is like this one. So each period have same number of orbit. That is, no cell or no orbit or shell added in a period. It is very important, though it appear very small, but students are committing mistakes. So once again, let us understand. Students, so if we consider the magnesium, aluminium, even sodium, even silicon, even chlorine. And let us take one more, oxygen and sodium. Sodium we had already taken. Understand this. We want to understand which of these are belonging to the same period and which one period. Then also in the group, which one group. So students, for that you have to first write down the electronic configuration. Write it. Say if I am writing for the sodium, sodium is 11. I will directly write KLMN. I will write at the top for only one of the element, KLM. So it is 11, 2, 8 and 1. Now take the other, magnesium 12, 2, 8 and 2. Aluminium 13, 2, 8 and 3. Silicon 14, it is our 2, 8 and 4. Let us take few more. We have taken for the oxygen, which have the atomic number. Yes, student, it is 8. So take it 8. Then 2 and 6. A student, we may take few more. Let us take the lithium also, which is 3, 2 and 1. We may take few more. Let us take the chlorine also, or let us take the carbon. which is 6. So for the carbon, we have 2 and 4. Students, here you are observing that all these 4, how many orbits they have? So each have 3 orbits. So depending on the orbits, the period number is given. So each of them, so each belongs to same period. Belongs to same period. What is that period number? It is your period number 3. Are you getting? So in the periodic table, in period number 3, we can get it. Now coming to the next 3, here we are getting how many orbit these have? Each have 2 orbits. What they are? They are K and L. Here if you want, you can write K, L and M. These are. Therefore, each of these will belong to, or each belongs to which group? No group right now. We are talking for number of orbits. So we shall talk for the same period. And which period? It will be in the period number 2. It will be. It is this one. Are you okay? So first thing, how to allocate period, that we have determined. Now let us come for allocating the group. About the characteristic of group we have learned, but for allocating the group, we have to look for the valence electron. So valence electron is 1. Is there any other element which have same valency? Yeah, it is this one. This also have the valence electron 1, not valency but rather valence electron. So wherever they have the same valence electron, they will fall in same group. This I had written earlier but not explained determining group and period, because without knowing period we cannot just allocate the group. See here, we had written that they have same valence electron. Following that valence electron, valency will also be same. But for determining the group, we need to know its valence electron. With the help of valence electron, we can determine the group. Understand this? So we are learning about how to determine valence electron and the period and the group. Now coming to the other one. Yes, students? Other one, what could be? The other one here you are observing, silicon have the valence electron 4 and carbon also have the same valence electron. Are you getting? So the valence electrons can tell us in which group it will lies. So right, same valence electron. Let me write for this. So same valence electron, each one is 4 here. This implies they are falling in same group. But the question is how to determine the group. So group is numbered 1, 2, 3, 4, 5. For that, you have to keep in mind, for initial one, you have to adjust it with the 10. Understand from this table before writing the formula for you people. Observe this carefully, student. Here you are observing For the element having valence electron 1, hydrogen, lithium, the group is 1. But coming for the 2, yes, it is also the 2. But coming for the electronic configuration of boron, how is this? It is 10 plus 3. So this 10 need to be adjusted everywhere. This 14, it is like our 10 plus 4. So 4 is valence electron. So in that you need to adjust with this 10. Ten plus 6, it is our 10 plus 7. It is our 10 plus 8. And we are knowing that 10 plus 8 is what? 8 is octet, which is very stable, that will not react. So as students, just keep in mind how to determine the group. For that I am going to write the formula at your level. So as students, here we are going to write this, determining the group and period, or first we may determine the group or period conveniently, and group of an element. So here we have learned that for determining the key feature is our electronic configuration. So first go for their electronic configuration. In their electronic configuration, we need to understand how much cells are there, like how much KLMN are there. If there is 2 cell, like in oxygen and lithium, we are able to understand these electrons are able to accommodate in K and L cell only. So number of cells gives us the period. So write the formula. So period, number of an atom or element rather, what will be the period number? It will be the number of cells in their electronic configuration. So it just count the number of cells in their electronic configuration. It is one thing. Then group number of an element. What we need to do? Here we have to keep 2 things in mind. Rather than 2, we shall keep 3 or 4 even. But at your level, 2 is enough. If the valence electron is 1 or 2, accordingly it will be group 1 or group 2. Okay? Then you go for increasing. If this valence electron is going to increase 3, 4, 5, 6, 7 or 8, accordingly it will be group which one? Plus 10. For determining the group is equals to 10 plus these valence electrons. Okay student, keep in mind it is this one. It is very important because question will be asked. How the question is framed, that I will also take. Then group number, the group number is equals to 10 plus their valence electron. This is the key that you have to keep in mind in determining this. Okay, how is this? Let us take. This much is enough for you. Even if you are going for D and F block, then again you have to adjust with the 18 or something else. But here this is enough. Up to your level, only this much will be asked. So write down a question at your level. We will come back to the property or trending in PDF, that I will come back. But first let us understand this. So write, an element have atomic number atomic number 16. Rather than giving the atomic number, sometime it is given that an element contains 16 electrons. That is, its atom contains 16 electrons. Rather than atomic number, only this number of electron in that species will be given. Getting no? It is that much. So an element have atomic number 16, and element X. Give the symbol to this element as X. Okay, student? Put the symbol X here. So the element X have atomic number 16. Then find its position in modern periodic table. Okay, it is this one. Let us see. A student, what to do? Element X with atomic number 16. Go for electronic configuration. So go for writing this 2, 8, 10 and 6 only. But for that, how much cell are required? K, L and M cell. So here what we are getting, how many cells are there? 1, 2 and 3 cells are there. Therefore period is equals to third. Now, so considering this number will give us the period. What for the group? Just observe the last number. Last number is 6. What is this? It is greater than 2, students. If it is 1 or 2 falling, then it will be 1 or 2. But if it is more than 2, like 3, 4, 5, we need to adjust it. Getting no? So it is greater than 2. This implies this can give us the group is equals to 10 plus whatever this 6 is there, that we need to. So the group number where it is going to fall is our 10 plus 6 is equals to 16. So 16th group. Therefore you have to write the final answer as X belongs to 16th group and third period. Sometime you need to identify this. What is this element? What is this element X? Which element? So just by atomic number we can say that. So our atomic number here for X, the atomic number Z is 16, and this is corresponding to, yeah, which one?
The sulfur.
Good. So it is for the sulfur. So X is our sulfur. Get it? You can allocate this sulfur in that, and we shall match whether it is in 16th group and third period or not. Okay, student? So let us go in our periodic table. We are going to end. Hardly 10 minutes more is required for me. Okay, so don't be impatient. We have discussed everything, even a very small thing we have discussed. So students, 16th group and third period. How to move third period, student? Take the third period. Third period is our 1, 2, 3. Are you getting this one? This way you need to move. And 16th group, where is 16th? So above it is written, it is our 16th, moved like downward. Where these two are cutting, two are cutting at sulfur itself. Are we getting? So this way our allocation is correct. Can you do like that? So one question is always asked, in which group and which period it will lie. So it is very convenient, but you have to practice a bit more, and rather it is very easy. Students, take me one more question. So an atom Y have, let us consider the 20 electrons, then find its position in periodic table. But if it go to 21, then how is the formula? That I will also explain here itself. Students, so take it 20, Y as 20, Y as 20. Write down their electronic configuration. K, L, M means first distributed 2, 8, then 8. Then because if I can put by 2n square as 18 here, the Bohr's rule means outermost cannot have more than 8 electrons, that is being violated. So therefore 2, 8, 8, and again 2 is there. And n. So what will be the period here? So this tells us that period is 4th, but this tells us that the group is, since it is 2, so keep it 2. Okay, it is this one. Now if it is asked for the 21, 22, 23, then what? A student, in that case you must have to keep in mind for a moment, though rare chances of asking, because there is another cell, D cell arises, so there no need to add. So a student, we need to modify our formula that it is this one, means if it is greater than 2, then 10 plus valence electron, it is for our, the better term is p block element, but you cannot understand this p block element. What is this p block element? So at your level you just keep in mind up to atomic number 20, and even more than 20 the same formula need to be applied, but at your level up to 20 is enough for you. But even if it is going to increase from the 20, then you need to continuously add in it. So if rarely or hardly if it is asked for that, otherwise in your academic it is not going to ask. If atomic number Z is greater than 20 to 20 element, that is our Z is equals to 20 here for this. If it is greater than this one, then your group number, you just simply consider it as the valence electron. But again, how long we shall continue? A student, for that, if you are coming to the periodic table, you can understand one more, a small thing. A student, observe it. For even 21 you are getting, it is falling in the third group. Observe this table once more. Observe it carefully. If I am coming to the 21, then I cannot apply the formula that I have told you, just add the 10, because there is a gap of 8 for the first, second and third period only. After that there is continuation, so no need to take a gap in our periodic table. So the group will directly 3 and the period will, this cell will be 4th, so it will be 4. Get it? So you have to keep in mind for the first 3, for the first 3 period you have to adjust it. Even for the first period you have to adjust with how much? By the 16, or just you have to keep in mind at the end. But for the other one, if you have doubt, adjust with 10. So here adjustment is required, because you will learn in higher standard that whatever this group now, just let me write few things for you. Why we are doing like that? A student, here, if you are considering only this much, you will find that these have 1 and 2, and these 1 and 2 electrons are going to fall, means the outermost electrons are going to fall in their s orbit. These, all these, their outermost electron going to fall in the p orbit. Therefore it is also called as the p block. This is the electronic configuration in the term of SPDF. Then if you are considering this one, these are D block. In this D block, no need of adjustment, because S and P are being separated by D. Therefore we were adding 10 to get the number for first 3, or even for the second and third. But for the fourth onward, you have to write this as it is. So these few things you have to keep in mind. And the last one, this one is called F block. So 4 block based are there. That's why the structure is not the rectangular array, rather there is a gap and gap. So this is the block one. So students, we have to keep in mind, at your level only up to 20 is enough, no more than that will be asked. But even if it is asked for the 21, then you directly write their valence electron number, that will give you for D block element. Let me take one example. Say if it is just asked for you to allocate the atom or element X with atomic number, say 24, or we may take the 26. That may appear you good. What we can write for this 26? Or better to take the 24 at your level, because it will never go more than 21, 22 or 23 or 24. Let me take the 23. It is our atomic number. So write for this X 23, because in NTSE even 21, 22 have also asked. NTSE have also not crossed the level of 23 and 24, because some other concept of chemistry arises. So right, it is our 2, 8, 8, and how much this become 18, and left one is 5. Get it? So this way we are observing that it is K, L, M and N. In this case you need not adjust with 10. Here this will give us the period 4th period. But in this case we are getting that this is the 5 itself, and the number is greater than 20, so directly it will give us the group number 5. Let us match it for the 23. See, where is our 23 students? We can get, yeah, 23 is our vanadium. Observe it. 23, the 4 element was there, means this one I shall consider, and the 5th this one. So it is the vanadium. Get it? It is this one. So this way you have to keep this thing at your level in mind to allocate it, even to get the answer at your NTSE level. But in higher standard, you will learn about the SPDF electronic configuration, and there, by knowing SPDF block, you can write it quickly. That is even more convenient, but your level it is difficult to explain those things. Otherwise, I need another 3 or 4 hours to teach this electronic configuration by that way. So student, this was all about our determining the group and period. Now the last thing we are going to write is about the trending. Students, here we have understood, or we are writing about the period. In our period, same number of orbits, it is one thing, and this orbit number gives the period number. So number of orbit, no orbit or cell added in the period. So each period have same number of orbit, and period number is same as our, we can write here, or let us go for here, period number same as number of orbits. This we have learned. Now what are the important other trendings that we are going to write? Trendings from left to right I will write. Trendings in period. Once we have understood about the group, trending in period is even more easy. So this period from left to right, left to right we are going to understand. Means from this to this I will move like this. Any of the period, whether first, second, third, fourth, all these things. So very first is in the period, what is there? No cell addition. Let me write it again. No any orbit or cell addition. Why this? Why I am writing it again? You will get the answer very quickly, because this is the very important thing with help of which we are going to conclude the other factors. No any orbit or cell added. But at the same time, the electrons are added in their outermost orbit. Means the valency is increasing, but electrons are added in their outermost orbit. So while electrons are added at the same time, their atomic number are also increasing, the number of proton in their nucleus is also increasing, but electrons are added in their outermost orbit for higher element. Higher element means higher atomic number element, you may write if you have the doubt. Higher atomic number I am talking for up to that much atomic number which are falling in same period. If it is getting repeated after interval of 8 or 18, then I need to consider for the next period. So in one period I am considering for higher atomic number elements. So higher atomic number elements means more protons added in their nucleus. Protons added in their nucleus. A student, when more protons are added in their nucleus, it means, what about the force of attraction between proton and electron? In this case, we are observing that electrons are going to placed at the same distance, but the positive charge at the center is going to increase. As a result, the attraction will increase. See, because these two are the basic for giving any property or for all kind of trending in a period. So we have to understand this. Let us consider Mg and even sodium we may also consider. Let us consider the sodium, magnesium and aluminium. For these three I am considering. So write down the electronic configuration: 281, 282, then 28, even 3. Even you may take the other one also, it is up to you. Student, you may take the nitrogen, oxygen, fluorine, or you may take the silicon, sulfur, even chlorine. It is whatever you are going to take, the result is not going to affect. Silicon 2, 8 and 4. Let me put the phosphorus also. Put the phosphorus, sulfur, chlorine. 285, 286, then 287. This thing you are already knowing since class 9. 286. Student, now let us draw the atomic structure to understand the above two concepts. See, I am going to draw for the first 3 only. You may also take the other pair. The same thing is applicable. Right, for the sodium. For the sodium, their nucleus having 11 proton. Better to write this with the 11 proton. 11 proton. K cell, L cell, M cell. Okay. For magnesium, I need to take the 12 proton, K cell, L cell and M cell. What is being drawn? Let us consider for the aluminium, where I need to keep 13 proton at their center. A student, now observe it carefully. It's very important. Only 2 electrons in this K cell. 1, 2, 3, 4, 5, 6, 7 and 8 electrons can be kept in. A student, are you getting this? Inner one is our nucleus. Okay, no? If you have doubt, we can hatch it. But only 1 electron here. Coming to this, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. In the other one, we have the 2 electrons. Now, coming to the other one, K have 2, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3 electrons. Now, student, you please start thinking. Is there any cell added? So all have 3 cells. Here all have 3 cells. Cells or orbits mean the same thing. This means all of them will belong to period number, which period? 3. Now coming to their size and other thing, that can be concluded. Now observe, for this first sodium, there is only 11 proton in their nucleus for this sodium. But for magnesium, there is 12 proton. But for aluminium, there is 13 proton in their nucleus. Students, so these 11 protons means this 11 proton is going to attract these other electrons, even the outermost electron also, in addition to the other electron. Okay. Now in the case of magnesium, we have the 12 protons. Now see, when this inner one, here the charge have increased, means the center become more strong, though this orbit may be trying to live at the same position as for the sodium, but while the center positive charge is more than this electron, so this center nucleus is able to attract the electron with a stronger force. Okay? Even we come for the aluminium, where there is 13 proton at the center, means the center is very much strong. It is able to pull these electrons heavily toward itself. So because of pulling of electron, what will happen? The outermost electron will start revolving closer to it. It will not collide, but the size of this orbit or outermost orbit is what? Circulation path. That circulation path will now reduce. Getting? So the size become smaller. Are we getting now? So it's very simple. So right, all have 3 cells, means the third period, but so right, with addition of or with increase in atomic number, without addition of, because in a period there is no addition of this cell, so without addition of this cell or orbit, means their atomic number is increasing, means the proton is increasing. Without addition of orbit, the nuclear charge so right, the nuclear force of attraction over the electrons increases, over the electrons increases. When the nuclear force of attraction over the electrons increases, so electron will start revolving in a smaller orbit. Getting? So the size of atom is what? The size of outermost orbit over which the electron is revolving. Getting now? So the size of atom decreases. That is, atomic radii decreases. Getting? It is the key thing. So here the size in the period decreases, but in group moving down the size was increasing. The factors are different. In group it was addition of extra cell, though the size was increasing, but in the period there is no extra cell added, rather the electrons are added and protons are added, so their force of attraction increased, so the size decreases. So write it. So atomic radii decreases. So it is the very first and very important. The question, how the question are asked? The question based on this are very simple. Arrange these in increasing atomic radii or atomic size. Atomic radii. Okay, student? I am just taking the fluorine, nitrogen, oxygen, even we may take the lithium also. Nitrogen, oxygen, lithium, all are in the same period. So always either it will be given for the same period, one period and other group, that kind. There are other consideration also come into picture. You can also write, but that kind of question is not belonging to your standard. That kind of question is asked in class 11th. So for this, let us write the size of this. So student, very easy again. Increasing atomic radii. So what we need to write first? So a smallest radii, then increasing the size. So observe it. Better thing is write their electronic configuration. Electronic configuration of fluorine, which is 9, your 2 and 7. So this next one is our nitrogen, which is 7, 2 and 5. The next one is our oxygen, 8, 2 and 6. Even for the lithium or for the carbon, we can also write carbon is our 6, 2 and 4. Even for the lithium, it is our 2 and 1. A student, here we shall keep in mind all of these have the 2 cells. So each have 2 cells. After these 2 cells, what comes into picture? We shall look for in which group it is laying. So higher the group, smaller the size. So in a period, means in the same period, in a period, higher the group, smaller its size. Smaller its size. So that concept. So which one is laying at the highest group? So highest group will have the lowest atomic radii. Here increasing atomic radii. So first we have to write for the lower R to higher. Lower R means lower radius, means higher group. So it should be in the higher group, should be written first, provided in same period we are considering. So all are in this second period. So with higher group means it should be the higher valence electron. So quickly after this, writing this, you can quickly write. So it is for the 7 one. So fluorine will be the first. Then coming to the 6, 6 is for oxygen. Then coming for the other 5 for nitrogen. Then coming for the other one, 4 for the carbon, then it is the lithium. Okay, student, this way we can write. So this size is increasing. So whether increasing or decreasing, you should be careful. It is, if it is asking the increasing and you have written the decreasing order, your marks will be deducted. So be careful. So this was all about their atomic radii. After knowing atomic radii, other characteristics are based on their atomic radii. So we can write just in one line, how will be the ease of losing electron or gaining electron and their metallic characteristic. So students, metallic characteristic is just opposite to their size. Getting now? Means the tendency of losing electron. So that will what? While you are moving, the size getting decrease, so tendency to lose electron will decrease. So metallic characteristic will decrease. So let me write first the tendency to lose electron. So tendency to lose electrons decreases. How is that? So therefore, if we consider the element like aluminium, magnesium and sodium, then which have the better tendency to lose? Students, you are getting here that size wise it is of the biggest, largest size. This is even smaller than that, even smaller than that. So the tendency to lose electrons in aluminium will be lesser than sodium will be maximum. So the tendency to lose electrons decreases. So this I have written in the increasing order of tendency to lose electron. Or in the decreasing order you may write, you may take the other one or the same one we may take. We may take the potassium, then the calcium, then the other one, or potassium have more tendency or better tendency than the calcium. So tendency to lose electron I am writing. So potassium have better tendency to lose electron than calcium. You may write titanium, vanadium, okay, scandium, titanium, vanadium, but these elements are not in your syllabus. That's why I try to avoid it. Okay, student. So this way tendency to lose electrons decreases. It means what? This simply means metallic characteristic decreases. And considering this metallic characteristic, it is found that all the metals are on the left hand side and non-metals are on the right hand side in this periodic table, and this metal and non-metal are separated by the central element called metalloids. So write this important point. Therefore, and even this we have also learned in our metal and non-metal. Therefore, all metals on left side, non-metals on right side, and intermediate means in between, and intermediate means in between them is metalloids. Okay, student, let us understand this in our periodic table. So this statement is also very important. So in MCQs, questions are framed. Metals are placed on right hand side, lower, left, upper. Okay, so all the metals are on the left hand side. Let us allocate it quickly. We are about to end the class. Nothing is left. Student, are you getting? Color code is already given in this table where we are observing that all these elements, what are? Observe this. These elements, these are the metals. Okay, student. Considering the other, what is the other one? We may write from or take from this here. These are our non-metals. And this metal, and in between metal and non-metal, still we have some other kind of thing. What is that? These are falling to the category of our metalloids. Metalloids. Are you getting? So this is the left hand. Even these two series are also falling in the metal category. Okay, now these are the metals. These are called a transient metal, transient element, and transition metals. Okay, so it is all about the metals, placing the metal, non-metal that we have written. So with this, we have understand about the metal characteristic. Now if we consider the tendency to gain electrons or tendency to form their oxides from metal to non-metal, that also increases. So right, tendency to lose electron decreases. This implies tendency to gain electrons, what increases? Tendency to gain electrons, it is expressed as non-metallic characteristic. Therefore, non-metallic characteristic, metallic characteristics increases. From where to where? From left to right. Okay, student, these are the things that we need to keep in mind. The size we have learned, size is most important. Then the same is for the atomic radii, the metal characteristic. A student, so tendency to gain electrons increases. So which kind of ion it will form? So right hand side element or non-metals form the anion. Therefore, rightmost element, right side element, what they are? They are the non-metals, form anion. Sometimes it is asking the term of anion and cation. And what about the left side element or metallic characteristic? The left side element will form cation. Okay, while left side elements form cations. Okay, student, left side element are what? Metals. Okay, so all these are basically the advantage. If it is asked for advantage of the modern periodic table, each of these can be written. So very good trending is there. Okay, regarding their characteristic, their metals, their oxide formation, all these things. So this way, the tendency to gain electron is called as electron affinity. Like ionization potential, there is another term called electron affinity. So, right, tendency to gain electron is expressed or given in the term of electron affinity. So, write the term like electron affinity. It was asked once. So, it is the tendency to gain electron. Tendency to gain electron. By an atom. This can also be expressed in the term of energy, okay now, but you will learn those things in the higher standard. I do not want to make it more complex. So how much energy will be released when electron is added to the atom? That is called as their electron affinity. Okay, it is like that one. So this tendency to gain electron to an atom, this is increasing on moving left to right. Therefore, we can simply write electron affinity increases from left to right in PDF. It is all about everything. So these were non-metallic characteristics. So let us highlight it. Electron affinity, this trending, then their non-metallic characteristic, their metallic characteristic in the period. Everything we have learned. Tendency to lose electron means the IP. This tendency to lose electron means what? Ionization potential. The student, this may be asked in the term of ionization potential. So ionization potential, tendency to lose electron means the energy required will increase in group, not in period. Here we are writing from left to right. Okay, now it was this one. So maybe asking the term of ionization potential, electron affinity, all mean the same thing. You have to understand it and answer it. The main cause behind everything is increase in atomic number. Okay, now which gives to increase in nuclear attraction. Because of higher number of protons, I had explained so many times, the order can be written. Electrons added in their outermost orbit, no orbit addition. So this is about the trending that we have written. Then we have learned how to determine the group number and period number and what are the various trendings. It is all about our periodic table. This way we have finished our chapter. Just 1 minute, hardly 1 minute. A student, please do not skip. Once it was also asked, we have learned that this periodic table or modern periodic table have so much advantage. It have make the study very convenient. Okay, but is there any limitation? Yes, limitations are also there. Still there are some limitation of modern periodic table. Okay, what are the limitation? I'm going to just write. The position of hydrogen is still anomalous. That can be kept in group 1 as well as in the group 17. Why? Electronic configuration matching with 1 as well as the 17, because for octet or duet formation 1 electron is required, and just by considering the k element filling of cell only 1 electron is there. So position of hydrogen is still anomalous. Okay, means This can be in group 1 or which group? Group number 17. Okay, student. Here the number is direct 1 to 17, not the 8. This one. The other limitation, lengthenide and actinide series are not given a space in main body. So write lanthanide and actinide series are not in main body of the periodic table. These two are the limitations. A student, sometime it is asked for what is the advantage over the Mendeleev table, okay, of this modern table. For that, write just one or two important things. So additional feature, additional advantage, feature or advantage. A student, whatever the earlier advantage of that Mendeleev periodic table, most of the advantage are also available here. So let me write that one also. Very first, ease of study, ease of study. Okay, the next one, many more features are there. Easy trending, and predicting properties. What properties? Atomic size, metallic characteristic, their compound characteristic, their valency, valence electron, each and every, all these property can be predicted. Whatever the possible trendings we have written, all those trendings, getting no, all are falling in the same or in the category of this trending. So trending and predicting properties. The third one, easy position of noble gas. So noble gas positions, which was missing in all earlier periodic table, which was missing in all earlier periodic table. Okay, student. What else? Yes, student. Can you recall what was the drawback of Mendeleev? The important drawback was regarding their isotopes. But isotopes, we are knowing that elements or atoms having same atomic number. So if the atomic number is same, all the isotope will placed at the same position. So position of isotope is given here. Position of isotope at, means all the isotope basically at the same atomic number. That is, all isotopes at same position. All I think this pen have also tired for writing, though I am not tired that much, but still a bit get tired. So that is all the isotopes are at isotopes of same element, getting no, isotope of one particular element. Let me write, because the question is asked from here. Isotope of one element at same position. It is this one. Okay, student. So these are the few additional advantages. Many more other advantages you people can write. In this, the position of isotope is very important. So all the isotope of same element have the same position. It is very important. The problem that still exists, position of hydrogen, it is the anomalous position. Okay, so in limitation, please do not forget these two things: position of hydrogen, and in advantage, position of isotopes. Other things are quite common. Okay, so this was all about our periodic classification of element. If my student have any doubt, any of my student have any doubt, then they may ask. Yes, student. Hope you people might have enjoyed the longest class of the year. I hope so. So, a student, your homework is blue question of our textbook, all the blue question, all the exercise questions. Please do, and please ask it tomorrow, means in our next class. This is all about. Next one is, please do the revision of maths. Please do it frequent revision, and please concentrate for few more time. It is important time. Then we will go for the frequent revision of the chapters. Yeah, student, any doubt, then please ask, otherwise I shall stop the class. You people also be getting tired. Can we stop? Yes, students, shall we stop, or still you want to have any question or any doubt? Yeah, tell me quickly.
Yes, sir.